Let's talk about sustainability. You've probably come across the word sustainable at some point in your life. If I decided to continue to talk for the rest of this video without taking a breath, you might tell me, Mia, that's just not sustainable. In this scenario, which I obviously would never even dream of attempting, I'd be depleting the oxygen in my lungs without replacing it. Using resources faster than they could be replenished is not sustainable. But what does sustainability really mean? Well, the word sustain means to maintain or to hold. So sustainability is the ability of something to be maintained over a period of time. In environmental science, when we talk about sustainability, we're talking about the ability of the Earth's systems to survive and adapt to changing environmental conditions and maintain the health of ecosystems. It's like a delicate balance where each process doesn't take too much or produce too much, so that all the other processes can keep on going. And theoretically, when all these processes are doing their jobs, this balance could last forever. But some things that humans do can disrupt this balance. Let's take a look at an example. In the early years of the United States, enslaved and free farm workers in the American South planted or were forced to plant cotton, a plant that needs to use the nitrogen in the soil to survive. But when they planted cotton in the same fields year after year, the cotton plants would deplete the nitrogen levels in the soil. This constant depletion of nitrogen was not sustainable, and the cotton crops suffered. In the early 20th century, agricultural scientist and inventor George Washington Carver suggested that farmers could alternate between growing cotton and growing nitrogen-fixing plants, like peanuts or sweet potatoes. This is a more sustainable way of farming, as the nitrogen-fixing plants would replace the nitrogen that the cotton plants took out of the soil. Since then, we've discovered a way of putting nitrogen back into the soil using chemically synthesized fertilizers. But sustainability is more complicated than just replacing depleted resources. When farmers use too much fertilizer or use poor methods of fertilizer application, all that fertilizer can run off into neighboring waterways. This excess nitrogen in the water could cause a lot of algae to grow. The thing about algae is that when it grows too rapidly, it also dies rapidly, and the microbes that decompose the algae hog the available oxygen in the water, which makes it difficult for other organisms living in the water to breathe. So when the fertilizer runoff causes too much algae to grow, it creates an imbalance in the ecosystem and harms the other organisms that rely on the dissolved oxygen in the water. So the addition of too much fertilizer is also unsustainable. But how could a farmer know whether they're using fertilizer sustainably? Well, they could look out for environmental indicators. Environmental indicators are basically when the Earth tells us, hey, there's something unsustainable in this ecosystem. But instead of just telling us that straight out, it tells us in a variety of clues. For our farmer, environmental indicators can be things like the amount of dissolved oxygen in the water, the biological diversity in the area, or even how much algae grows in nearby water sources. The series of events triggered by fertilizer pollution could deplete the amount of oxygen in the water. So species that live in the water that require a lot of oxygen to survive could begin to die off. These species are called indicator species because they're known to survive in very specific circumstances. Spotting these species is an indication that there is a lot of oxygen in the water. If these species are absent, then that will be an indication that the pollution has reduced the amount of dissolved oxygen in the pond. The farmer could then change their behavior. In this way, environmental indicators can guide humans to make sustainable choices. Another way humans can use environmental indicators to make decisions about natural resources is by monitoring populations and estimating their growth. Imagine that you have a pond in your backyard. And let's imagine that you have searched for all of the correct environmental indicators, so you know that the fish in your pond are not suffering from pollution. One day, you decide to go fishing. It might be tempting to fish as much as you can, so that you can invite all of your friends and have a big, happy fish feast. But if you decided to take all of the fish out of the pond, then there wouldn't be any left to reproduce. So your feast next year would be pretty sad. Even if you just left a couple of fish in the pool, they might not be able to reproduce enough to replenish the population. Other environmental factors might cause the small fish population to go down even further. The fish might catch diseases, run out of food, or end up being some other creature's feast. There's some maximum number of fish that you could take, so that there's enough fish left in the pond to reproduce and replenish the population. This number is called the maximum sustainable yield. Basically, you want to catch the most fish to have the maximum yield while still being sustainable. If you fish more than the maximum sustainable yields, then the fish will be captured more quickly than they can reproduce, and the population will slowly decline. If you fish less than the maximum sustainable yields, then the fish population will grow exponentially until they reach the maximum capacity that the ecosystem can support. Some of the fish will eventually die from density-dependent factors like lack of food and disease. On a bigger scale than your imaginary pond, natural resource managers try to estimate what the maximum sustainable yield will be each fishing season. This is why fishery managers regulate the amount of certain types of fish each fisher is allowed to catch per year. This is to make sure that next year we will still have fish. So if we study the Earth's ecosystems and understand how we impact the environment, then we can find ways to interact with ecosystems more sustainably. And really, that's what environmental science is all about.